This question is to calculate expected profit based on variable demand, setting up a piecewise function, and using calculus to determine the optimal number of books to stock. Please subscribe to our YouTube channel Math Tutor 8285. Your subscription fuels the passion. Let's grow together. Thank you so much. An online bookstore is preparing to sell a limited edition poetry book during a seasonal promotion. For every copy sold during the promotion, the store earns 12 yuan. Unsold books, however, must be returned afterward, causing a loss of 3 yuan per book. Based on past records, the number of books customers want to buy, which we call D, is equally likely to be any number between 60 and 120. How many books, which we call Y, should the bookstore stock before the promotion begins to maximize their expected profit? First step is to understand the variable and profit structure. We let Y represent the number of books the store stocks. The actual number of books people want to buy is D, and D follows a uniform distribution between 60 and 120. Now, depending on how Y compares to D, there are two possible cases. In the first case, if demand D is greater than or equal to the number of books stocked, Y, then every book is sold, and the profit is 12 times Y. In the second case, if demand D is less than Y, then only D books are sold, and the rest are returned at a loss. The profit in that case is 15 times D minus 3 times Y. So the total profit depends on whether the actual demand D is below or above the number of books stocked. Next step is to express the expected profit. Since the demand D is uniformly distributed between 60 and 120, each value of D in that interval is equally likely. This allows us to compute the expected profit using two integrals. For the first part, where demand is less than Y, we calculate the expected value of 15 times D minus 3 times Y, average across all values of D from 60 to Y. For the second part, where demand is greater than or equal to Y, the profit is always 12 times Y, so we average that over all values from Y to 120. Next step is to evaluate the expressions. When we carry out the integration and simplify both parts, we find that the total expected profit becomes the sum of two terms. The first term simplifies to negative 1.5 times Y squared plus 180 times Y minus 27,000, all divided by 60. The second term simplifies to 1/5 of Y multiplied by 120 minus Y. Putting both parts together, we get a single expression for the expected profit that simplifies further to the following: negative 27 times Y squared plus 3,240 times Y minus 54,000, all divided by 120. Next step is to maximize the expected profit.